Alright, in this video we're going to go over all the cheats or basic understandings of Newton's laws in order to do well on our test. So before each question you have to ask yourself, is there a net force acting on this object? Is the object accelerating or is the acceleration zero? You can still be moving at a constant speed and have zero acceleration. So even if the problem says the object is moving at a constant speed of 2 meters per second or 2 million meters per second, its net force is still zero. So if there is a net force acting on the object, then we're always going to say, yes, the mass times acceleration given, it has to have an acceleration, is equal to the sum of all the forces in the positive direction minus the sum of all the forces in the negative direction. And the friction force is always in the negative direction of motion. If it says no, if the object is moving at a constant speed, or if it's just sitting there on a table, then the net force is zero. The sum of all forces in the positive direction equal the sum of the forces in the negative direction. So the key is to draw a picture, let's say, and then solve that way. So something we've been working on lately is, here's a box, goes up an incline, and there's another pulley. So M1, M2. So let's say M1 is moving up the incline at a constant speed. How would we start to solve anything? They could ask for the mu value, they could ask for the mass of the other block on the side that's just going straight up and down. But in order to solve any of those questions, we must first draw a diagram of what's happening and figure out how the forces are interacting. So we say constant speed, so the acceleration is zero. Once the acceleration is zero, we have to look at the forces acting in each direction. So the positive direction of motion. So M1 is going up the incline. So in the positive direction of motion, the only thing that's making us go that way is the mass of the object 2, or M2. So just M2 times gravity. And that is equal to all the sum of the forces in the negative direction. Well, I have a component of gravity, not the whole thing, but just F sub g sub x. And then also there would be the friction force based upon M1. So this, for net force of 0, this would hold true for our scenario over on the right. Now I can solve for the mass of 2, I can solve for mu, for the friction force, I could even solve for the mass of 1 through a little bit of algebra and a couple of other given values. So there's no equation that I can tell you that will always be true in each circumstance. But if you can figure out which direction the forces are going, which are positive and which are negative, after you've already answered this question at the top, then you should be in good shape. Alright, so there are really about 4 equations that we learned in this chapter. Sigma F equals ma, that's on your equation sheet. Friction force equals mu times the normal force, also on your equation sheet. And the only other 2 things that I've told you before that you have to know is the force of gravity in the x is mg sine theta, and the normal force on an inclined plane is mg cosine theta. So if you've memorized that and you know that that's on your equation sheet, you're going to be in good shape. All right, good luck on your test.